Welcome to the deep dive. We're going to be diving deep into Apophis today.
Oh, yeah.
The asteroid, nicknamed the God of Chaos.
Right.
Pretty crazy stuff. I'm sure you've heard about it, the one that's supposed to come, like, terrifyingly close to Earth in 2029.
Yeah.
We've got a bunch of research and analyses to unpack today.
Yeah.
So let's just get right to it.
You're right. Apophis has definitely gotten a lot of attention, in the news and stuff. It was actually discovered a while ago, back in 2004.
Oh, wow.
And at first, people were genuinely concerned that it might actually hit us.
Oh, no.
On April 13th, 2029.
Oh, what a day to hit.
Imagine that, a chunk of rock the size of the Eiffel Tower just hurtling past, closer than some of our satellites even.
Okay, so that's officially nightmare fuel. But the latest research says it's going to miss, right?
That's what we think, thankfully. Follow-up observations have kind of refined its trajectory, and it seems like it will pass by us at a safe distance. But there's this new study by Paul Weigert, who's an expert in, solar system dynamics and stuff.
Yeah.
And he suggests that there's this tiny chance, less than 1 in a billion, that it could get nudged into a collision course by another asteroid.
Whoa, okay.
Yeah.
So we're talking like cosmic billiards here, with an asteroid potentially knocking Apophis off course and sending it, hurtling towards us. I mean, it's fascinating how these celestial objects can interact.
It's crazy.
But also kind of unnerving.
Definitely something to think about. Remember the DART mission?
Yeah.
NASA successfully changed the trajectory of an asteroid by crashing a spacecraft into it.
It's amazing they did that.
Yeah. And even a small asteroid impacting Apophis could, alter its course enough to make it a threat to Earth.
That's a sobering thought for sure. So how do we even know, which asteroids could pose a threat to Apophis?
Yeah.
Or are we talking about, undetected ones lurking out there?
Yeah, that's the tough part. Weigert's study actually looked into that very question.
Oh, wow.
And his earlier research actually ruled out any known asteroids colliding with Apophis.
Okay.
But this new study is exploring the chance that an undiscovered asteroid, maybe too small to detect or, hidden by the sun's glare, could be the culprit. He used computer models to simulate the probability of that kind of impact.
So we're talking about a phantom asteroid.
Right.
Potentially bumping into Apophis and changing its course.
Yeah.
That adds a whole other layer of complexity to this whole thing.
Yeah, for sure. And it really shows how important it is to just keep observing and researching.
Right.
There's still a lot we don't know about the smaller objects in our solar system.
Right. Speaking of observation, isn't Apophis currently out of sight?
Yeah, unfortunately, it's too close to the sun right now to be observed directly.
Okay.
We're going to have to wait until 2027 for it to kind of reappear. Once it's visible again, astronomers can study its trajectory more accurately and refine their predictions about it.
So we've got a few years to prepare.
Yeah.
But what happens after that?
Well, after its close approach in 2029, NASA is planning to send the OSIRIS-APEX spacecraft to Apophis.
Oh, cool.
You might remember OSIRIS-REx?
Right.
The mission that collected a sample from that asteroid Bennu.
That was incredible.
Yeah. Well, it's getting a new assignment, a close encounter with Apophis, to gather data and get a better look at its composition.
It sounds like this God of Chaos will be keeping us on our toes for a while.
Oh, yeah.
You mentioned other close approaches besides the one in 2029, right?
Yes. Models are predicting close approaches in 2051, 2066, and 2080.
Oh my gosh.
But the good news is, current projections suggest that Apophis poses no significant threat to Earth for at least the next 100 years.
Okay, so maybe we can breathe a sigh of relief, at least for now. But all this talk about a potential threat, it also brings up a question. Could we actually do anything to stop an asteroid like Apophis if it were headed straight for us?
That's the big question, right? And that leads us to the world of asteroid deflection technologies. One method that's particularly interesting for Apophis, with its metal-rich composition, is laser ablation.
Laser ablation sounds kind of like something straight out of Star Wars.
Yeah, kind of.
What is that exactly?
It's a very real and potentially game-changing technology. Imagine focusing sunlight with a magnifying glass to, burn a leaf.
Yeah.
Laser ablation works in a similar way, but on a much bigger scale, of course.
So we're talking about blasting an asteroid with a giant laser beam.
Well, not quite blasting, more like nudging. The idea is to use a powerful laser to vaporize a small part of the asteroid's surface. And as that material gets blasted away, it creates a tiny bit of thrust in the opposite direction, ever so slightly changing the asteroid's trajectory.
Right.
And because Apophis is rich in metals, which are great at absorbing energy from lasers, this method could be pretty effective.
It sounds incredibly complex, though. I mean, where would we even put this giant space laser?
There are a couple possibilities. One option is to position the laser at one of the Lagrange points,
Oh, okay.
which are stable points in space where the gravitational forces of the Earth and the Sun kind of balance out. Think of them as like cosmic parking spots,
Right.
perfect for long-term operations.
So these Lagrange points are like strategic locations for our asteroid deflecting laser.
Exactly. Another option is to place the laser in a solar orbit similar to Earth's.
Okay.
And then there's the most ambitious, but potentially the most effective option, placing it in orbit around the asteroid itself.
Orbiting the asteroid. Isn't that a little bit risky? I mean, especially as we're talking about a potentially hazardous one.
It would definitely be a challenge.
Yeah.
It would require incredible precision and like navigation and a robust system to handle the harsh environment of space.
Right.
But it would also offer the most direct and controlled way to do laser ablation.
I see the potential there, but this is all starting to sound very complex and futuristic.
Yeah.
Let's talk about the laser itself.
Yeah.
What kind of technology we're talking about here? Is this something we already have, or is it still in the realm of theoretical possibility?
It's kind of a mix of both. We do have powerful lasers here on Earth, but designing one that's powerful enough to vaporize asteroid material, compact enough to launch into space, and reliable enough to operate in the harsh environment of space.
Right.
It would require some pretty significant technological advances.
So this asteroid deflecting laser is still more of a concept than a reality at this point.
For now, yes. But research and development is ongoing.
Right.
Several types of lasers are being considered, each with its own advantages and challenges.
Like what? Give me some examples.
Well, one possibility is a neodymium-doped yttrium aluminum garnet laser,
Okay.
or NDYAG for short.
NDYAG, catchy. What's so special about that one?
Well, NDYAG lasers are known for their ability to generate very high power outputs,
Okay.
which would be essential for vaporizing asteroid material. Another contender is the ytterbium-doped fiber laser, which is highly efficient and can be scaled up to produce extremely high power levels.
So power is key here.
Absolutely. And to achieve the power levels needed to deflect an asteroid, we might even need to combine the beams of multiple lasers
Wow.
using a technique called beam combining. It's like amplifying the laser's punch by merging multiple beams into one super beam.
Beam combining. I'm trying to picture that.
Imagine merging several smaller streams of water into one powerful torrent.
Okay.
That's essentially what beam combining does with lasers.
Okay, I'm starting to get the picture. But even if we have these super powerful lasers, how do we make sure they hit the right spot on the asteroid? I mean, we're talking about a moving target, potentially millions of miles away.
That's where precision optics and sophisticated targeting systems come into play. We would need incredibly accurate and thermally stable mirrors and lenses to focus and direct that laser beam over vast distances. And of course, a very sophisticated tracking system to constantly monitor the asteroid's position and make real-time adjustments to the laser's aim.
So it's not just about raw power.
No.
It's about control and accuracy as well.
Yeah.
This is starting to sound like the ultimate space laser challenge.
It is. And we haven't even touched upon the engineering challenges of keeping the laser cool in the vacuum of space, or preventing the debris created by the ablation process from becoming a hazard to other spacecraft.
It sounds like a massive undertaking, requiring a whole host of technological breakthroughs. But is it even realistic to think we could develop something like this anytime soon?
That's the question that scientists and engineers all over the world are trying to answer.
Yeah.
The challenges are huge, but so are the potential rewards. After all, we're talking about potentially saving our planet from a catastrophic asteroid impact.
Right.
The stakes couldn't be higher.
It's incredible to think that we're even having this conversation just a few decades ago. The idea of deflecting an asteroid with a laser would have been pure science fiction.
I know.
Now it's a real possibility
It really is.
that's being actively explored.
Yeah.
It's a testament to, like, human ingenuity, our drive to push the boundaries of what's possible.
It really is.
And who knows, maybe one day, laser ablation will be the key to protecting our planet from the threat of asteroids.
Oh, absolutely.
Well, it's a comforting thought. I'm definitely feeling a little less anxious about Apophis now. Knowing that brilliant minds are working on solutions to this cosmic challenge.
Yeah,
It's amazing.
it is.
But before we get too comfortable, there's another aspect of Apophis that I think we need to explore.
Okay.
It's the potential for this god of chaos to actually become a source of wealth and opportunity.
Oh, interesting.
You talk about asteroid mining.
Yeah.
I've heard whispers of this, but it's always seemed like something straight out of a science fiction novel.
It might sound far-fetched, but it's becoming increasingly plausible.
Wow.
Remember, Apophis is a metal-rich asteroid, potentially containing vast amounts of valuable resources, things like nickel, iron, and even precious metals.
So instead of a threat, Apophis could actually be a treasure trove floating out there in space.
Exactly. And that's a concept that's capturing the attention of entrepreneurs, scientists, and governments alike.
This is where it gets really interesting. Let's delve into the world of asteroid mining and explore the potential, the challenges, and the ethical dilemmas of tapping into these cosmic resources.
Let's do it.
All right, let's dive in.
Mining asteroids, especially one like Apophis,
Yeah.
it's a concept that sparks both excitement and concern.
Right.
It's like we're on the verge of this whole new frontier, one
Yeah.
that could totally change how we access resources.
Right.
But it also makes you think about, our relationship with space in a whole new way.
It really does. It's mind-boggling to think about how much potential wealth is just locked away in these celestial bodies.
I know, right?
We've always looked to the stars with wonder, but now we're starting to see them as this source of tangible value. What would it even look like to mine an asteroid like Apophis?
Well, there are a few approaches being explored, each with their own, pluses and minuses.
Right.
One idea is to capture the asteroid and bring it closer to Earth,
Wow.
maybe even into orbit around the moon.
Okay.
This would make getting to the resources a lot easier,
Yeah.
but it would require a massive engineering effort to move such a huge object.
Redirecting an asteroid.
Yeah.
That sounds like a task of epic proportions.
It would be, for sure.
What are some of the other options being considered?
Another approach is to develop, robotic mining operations directly on the asteroid's surface.
Okay.
This would involve sending specialized spacecraft,
Right.
equipped with drills and grinders and stuff, to extract the valuable materials.
So picture swarms of robots crawling all over Apophis,
Yeah.
extracting metals and other resources.
Right.
It's something out of a movie.
It's becoming less fiction and more science every day.
It's amazing.
The potential payoff is huge. I mean,
Yeah.
some estimates suggest that Apophis alone could contain trillions of dollars worth of metals.
Trillions. That's an astronomical sum.
It is.
It's no wonder that asteroid mining is getting so much attention.
That's crazy, yeah.
But I imagine there are some pretty significant challenges
Oh, yeah.
before we're extracting resources from Apophis on, an industrial scale.
For sure. The technological hurdles are substantial. We're talking about operating in an incredibly harsh environment, extreme temperatures, radiation, micrometeoroids, and
Yeah.
the vacuum of space.
Right?
It's really tough.
So how do we even...
Developing equipment that can withstand those conditions and function reliably over long periods.
Right.
It'll require some groundbreaking innovation.
It does sound like a monumental engineering challenge, even if we set aside the whole logistical side of things.
Right.
Getting the equipment and personnel out to the asteroid in the first place.
Yeah.
What about the economic side of things? Is asteroid mining even financially feasible at this point?
That's another big question.
Yeah.
The initial investment would be enormous.
Right.
And it might take years or even decades to see a return.
Wow.
Plus, you got to think about market demand.
Right.
If the supply of resources from asteroids suddenly goes up,
Yeah.
what impact will that have on prices here on Earth?
That's a crucial point. We can't just assume that asteroid-mined resources will be profitable.
Yeah.
It's all about supply and demand.
Right.
And disrupting established markets can have unpredictable consequences.
Absolutely. And then there are the legal and ethical things to consider.
Oh, right.
Who owns the resources in space?
Yeah, that's a big one.
How do we make sure that asteroid mining is done responsibly and sustainably?
Right.
These are questions that require a lot of thought and international cooperation.
It seems like asteroid mining raises as many questions as it answers.
It does.
It's a fascinating prospect.
It is.
With the potential to, I don't know, maybe reshape our world.
For sure.
But it's also a venture filled with complexity and uncertainty.
I agree. And while asteroid mining might be the most tangible way to extract value from Apophis,
Right.
it's not the only thing that's captured people's imaginations.
Oh, you have my attention. What else are people envisioning for this God of Chaos?
Well, remember those more speculative ideas we touched upon earlier
Yeah.
about manipulating space-time and creating cosmic shortcuts?
Yes. The ideas that seem more like science fiction.
Yeah.
You're not suggesting those concepts are being seriously considered, are you?
Not exactly.
Yeah.
But the fact that people are even talking about them
Yeah.
is a testament to human ingenuity
Right.
and our desire to push the boundaries of what's possible.
I suppose it's hard to resist the allure of those big, bold ideas,
I know.
even if they seem a bit far-fetched right now.
Yeah.
It's that same spirit of exploration and
Yeah.
innovation that makes us want to explore space in the first place.
Exactly. And who knows? Maybe
Yeah.
one day we'll understand physics so well that some of those crazy concepts could become plausible.
I'm all for pushing the boundaries of scientific understanding.
Me too.
But I think for now, let's stick with the more grounded aspects of Apophis.
Okay.
We've talked about the potential threat,
Right.
the possibilities of deflecting it with laser ablation,
Yeah.
and the potential to mine its resources.
Yeah.
But amidst all these discussions about technology and economics,
Yeah.
I think we should remember the human side of this story.
I totally agree. Apophis, with its nickname,
Yeah,
has really captured people's imaginations all over the world.
I think so.
It's a symbol of how vulnerable we are out here in space.
Right.
A reminder that we're not immune to the forces of nature,
Yeah.
even those coming from millions of miles away.
It's humbling
It is.
to realize that this massive rock hurtling through space could just disrupt our lives in such a huge way.
It really makes you appreciate how fragile our existence is.
Yeah.
And the importance of trying to understand and mitigate these cosmic threats.
It does.
Yeah.
But beyond the fear and anxiety,
Yeah.
Apophis also represents something else, doesn't it?
What's that?
It represents wonder,
Yeah.
a challenge to our ingenuity,
Definitely.
and a reminder of just how vast and mysterious the universe really is.
It's like this cosmic mirror reflecting our fears and aspirations.
Right.
It makes us confront where we fit in and to think about the potential for both peril and progress in the face of the unknown.
And as we keep exploring the cosmos,
Yeah.
we're bound to encounter more objects like Apophis,
Oh, yeah.
more challenges to our understanding and our technology.
For sure.
It's a journey that will test our limits,
Definitely.
push us to innovate,
Huh.
and maybe even reveal our true potential as a species.
I think you're right. But before we get too philosophical,
Okay.
there's another aspect of Apophis that we should probably talk about.
Oh. I'm curious. What else do you have in mind?
The question of international cooperation.
Oh,
After all, Apophis isn't just a challenge for one country. It's a potential threat to everyone.
That's a good point. If we're talking about deflecting an asteroid or even mining its resources,
Right.
it's going to take a global effort.
Exactly. And that brings up some questions about how nations will work together or maybe even compete
Right.
when facing these cosmic challenges.
It sounds like we're getting into space diplomacy now,
Yeah.
where the stakes are really high.
Definitely.
The rules are still being written.
It's true. It's definitely an area worth exploring further.
Lead the way. I'm ready to dive into the world of international cooperation and how it all plays out with asteroid threats and opportunities. It's interesting to think that something as potentially destructive as an asteroid could actually bring nations together.
I know, right? It's like we're all facing this common enemy,
Right.
but instead of armies and weapons, we're talking about telescopes and spacecraft and international treaties.
That's a great point.
Mhm.
So what does this international collaboration actually look like? Are we talking about scientists sharing data, space agencies working together on missions, or even something more complex than that?
It's all of that and more, really.
But-
We already have a few frameworks in place,
Okay.
like the International Asteroid Warning Network,
Okay.
which coordinates efforts to detect and track potentially hazardous asteroids.
Gotcha.
And then there's the Space Mission Planning Advisory Group, which brings together experts from different space agencies to discuss and plan for potential asteroid mitigation missions.
So we're not starting from scratch. There are already organizations dedicated to this global effort.
Exactly. But there's always room for improvement,
Right.
especially as the stakes get higher and the potential for both conflict and cooperation increases.
What kind of conflicts are we talking about? I mean, wouldn't everyone agree that preventing an asteroid impact is in everyone's best interest?
In theory, yes, but in reality, things can get messy. For instance, if we're talking about deflecting an asteroid, there might be disagreements about the best method, who controls the mission, or even who gets the credit for, saving the planet.
Ah, so it's not just about the science, it's about politics too.
Exactly.
It sounds like there's potential for a lot of political maneuvering, even in the face of a global crisis.
There is. And then there's the issue of money, resource allocation. And we're
Yeah.
talking about developing expensive asteroid deflection technologies
Yeah.
or launching these ambitious space missions.
Right.
Who pays for it all? These questions can get pretty contentious.
And what about asteroid mining? Wouldn't that create even more potential for conflict as nations compete for those valuable resources?
That's a big concern. The current legal framework governing space is a little unclear when it comes to resource ownership.
Oh, really?
The 1967 Outer Space Treaty says that nations can't claim sovereignty over celestial bodies,
Okay.
but it's not so clear about the rights of individuals or companies to actually extract and use those resources.
So it's like a cosmic gold rush, but with the rule book still being written?
Pretty much.
That sounds like it could lead to some chaos.
It could, unless we figure out some clear guidelines and agreements beforehand.
Right.
There's a growing movement to create international regulations for space resource use.
Okay.
But it's a complicated process with a lot of different people and interests involved.
It sounds like a delicate balancing act, encouraging innovation and economic growth, while also making sure things are fair, sustainable, and peaceful out there in space.
It definitely is.
It's amazing to think that we're at a point where these aren't just hypothetical discussions anymore.
I know, right?
We're dealing with the real-world implications of asteroid threats and opportunities.
It's a whole new world.
It feels like we're entering a new chapter in human history, where the lines between Earth and space are getting blurry.
I agree. And as we keep pushing further into space,
Yeah.
the need for international cooperation, for a shared vision of humanity's future out there,
Right.
it's only going to become more important.
It's both exciting and a little daunting.
Yeah.
To realize that the decisions we make today about asteroids, about space exploration, about our relationship with the universe,
It's a big deal.
they'll have an impact for generations to come.
Absolutely.
It's a huge responsibility.
It is.
And one we should approach with a mix of humility and a sense of adventure.
I agree.
After all, we're not just exploring space, we're exploring what we're capable of as humans.
Well said. Well, I think it's time to wrap up this deep dive into Apophis.
Okay.
We've covered a lot today, from the science of asteroids to the ethics of space exploration.
Yeah.
We've talked about the potential for disaster
Right.
and the promise of incredible discoveries.
It's been quite a journey, full of twists and turns.
Just like the orbit of Apophis itself.
It really has.
Mm.
It's left me feeling a sense of wonder, a renewed appreciation for our planet, and a spark of hope for humanity's future among the stars.
I couldn't have said it better myself. Until our next deep dive,
Yes.
keep looking, keep asking questions, and keep exploring all the possibilities out there.
And remember, even when faced with cosmic chaos, there's always something new to discover, something to learn, and something to inspire us to reach for the stars.
I love that.
Thanks for joining us on this deep dive into the world of Apophis.
It was my pleasure.
We'll see you next time for another fascinating exploration of the universe and beyond.